given you a problem to solve last week before ending the class?
Yeah, I think it was it 11.6 or 11.7? Let me check.
It's 11.7. So did you get the answer for that?
1 second, I'm just checking my notes.
Okay.
Oh yeah, I see it. So it was solving for acceleration, and I got the maximum acceleration is 12.
Correct. Okay. So now we know how to find the velocity at any point of time in a simple harmonic motion. So now we'll learn about displacement. So if you have to give an equation for the simple harmonic motion, then it's given by x equal to a into cos of omega t, where x is the displacement and a is the amplitude, omega is the angular velocity, and t is the time period. Okay, and you also know omega is equal to 2 pi f. You would have learnt it in your circular motion chapter, correct? So if you substitute it here, you get x is equal to a into cos of 2 pi f times t. This you can convert it to the time period also. But what exactly is this doing? So let us say there is an object which is performing a simple harmonic motion. So after some particular time t, you have to know at what position the object is. So for that, you would use this equation. So this equation will let you know at what position the object is at any point of time. Let's solve a problem concept. So I want you to number 11.8.
Okay, so the amplitude is already kind of given, right? Because 0.3.
It's from this equation only you can get to know what amplitude is.
Yeah, so 0.3. And then for frequency, is it just 8?
No.
Or it's 2 pi f equals 8?
See, the displacement is equation is what? X is equal to a into cos of omega t. So here, omega is equal to 8, right? And what is omega? It's angular velocity, which is equal to 2 pi times f. So from that you can calculate f, right?
Yeah. So it's 8 over 2 pi.
Correct.
Which is I got the time as 0.787.
Time period. Okay. That's correct.
I got 2.3938 for the speed or the velocity.
2.293. Okay. Close to the correct answer.
2.393.
Correct. Perfect.
Wait, I forgot what the formula for acceleration was?
Just apply force is equal to mass into acceleration formula.
Oh,
So in
okay.
that, force is what? Ka, right?
Yeah, so I would just solve for A. I got 15.04.
15?
15.04.
No, that's not correct. So A max is given by K by M into A, right?
Yeah.
So in this, what is K? K is 2 pi F. K by M is 2 by F whole square, right? This ratio is 2 by F whole square that we had done in the previous class, right?
Mm-hmm.
So apply that and multiply this with amplitude, you get the maximum acceleration. It's 19 meters per second square. Answer.
Oh, when I squared 2 pi, I think I didn't square the F.
Okay,
So that
no
was
problem.
my
And then next concept is the simple pendulum. So in simple pendulum, you would be learning how the free body diagram would be, and then what is the time period for the oscillation, and also what is the frequency. These are the concepts which you'll be learning in the simple pendulum. So first, let's learn how to draw a simple, how to draw a free body diagram. So if let us say this is a fixed point and there's a pendulum. I'm considering one of the extreme positions, okay? And let us say this is the initial position and this is one more extreme position, okay?
yeah.
Correct? So this is a bob. So this bob will have a particular mass, and for that I'll write force due to gravity, which is mg. And let us say this is theta. If that is theta, even this is also theta, correct? So this would be mg cos theta, and this is the flow of the motion. So, and then this would be mg sin theta, correct? And since this is a string, there would also be a force which is due to tension. So this is how you draw a simple pendulum, right? Yes or no? Hello.
Yeah. Hello?
So got it right? How to draw a simple free body diagram.
Yeah.
So if you consider any periodic motion, there must be some sort of restoring force that brings back the object to its original position, right? So in this case, which is the restoring force? So out of all the forces which I've represented, which would act as a restoring force?
Mg sine theta?
So mg sin theta is the restoring force. So if I represent it in the form of equation, F restoring would be negative because it's opposite the direction of motion, mg sin theta. And then let us say the length of this string or any of the strings here is L, it's given by L, then you can say time period is equal to 2 pi into square root of L by G, and frequency is 1 over T. So this is what you have to remember. So time period is equal to 2 pi into square root of L by G. So if you look at this equation carefully, so in simple harmonic motion, time period was dependent on the mass of the object. But in simple pendulum, time period is dependent on the length of the string of the pendulum. Okay.
Okay.
So any doubts with respect to this concept?
No, so the mass doesn't matter in terms of time.
Yeah, whatever might be the mass of the object, it does not matter. It depends on the length of the string only. In case of simple pendulum. Okay.
Yeah.
So there's a derivation for this. Do you want me to do that?
Wait, for frequency?
For time period, there is a derivation for this equation. So will your school ask derivations in exams?
No,
So do you want me to do that? Or
that's okay.
okay. So let's solve a numerical on this concept. So I want you to solve question number 11.9. So next we will move on to the damped harmonic motion. So there are two types of harmonic motion. So one is a simple harmonic motion and second one is the damped harmonic motion. So first let us learn what's the difference between these two. So in simple harmonic motion, what used to happen that there wasn't any air resistance or there wasn't any frictional force. So if let us say a body was oscillating with an amplitude capital A, it used to continue to oscillate with the same amplitude as there wasn't any loss of energy. And whatever the total mechanical energy was there in the object, that was conserved at any point in time. Correct?
Yeah.
So if we draw the diagram for the distance versus time, where the distance is basically the amplitude. Okay. So if let us say this point represents the amplitude, then that always used to be the same throughout the motion. Correct? So this is how the graph would look for the simple harmonic motion. Right?
Yeah.
So, but in damped harmonic motion, what happens is there is the influence of the air resistance and also the frictional force. So, due to that, what happens is the total mechanical energy will not be conserved. And as the time passes, the amplitude of the oscillation keeps on decreasing and finally it reaches zero. So that's the difference between simple and damped. So if we have to draw the diagram for that, so let us say this is the maximum amplitude. So initially it'll have a maximum amplitude, then it'll decrease, then it'll again decrease, and finally it end up as zero. So if I draw the dotted lines like this, so you can see that the amplitude is keep on decreasing during the motion because of the influence of external forces like air resistance or frictional force. Okay, so that is what is known as damped harmonic motion. These two graphs are important. They might ask you in your MCQs. Okay.
Mm-hmm.